most of us know, bacteria are small organisms that grow rapidly and continuously. Just for some background information, bacteria usually grow by duplicating themselves, and this is called binary fission. Scientists and mathematicians use the exponential growth formula to calculate the population changes in a bacterial culture dish. They use this formula when bacteria are grown in a controlled environment with a constant supply of food. The equation for bacterial growth is A is equal to A subscript 0 times e to the k times t power. A is the total population, A subscript 0 is the initial size of the population, E is equal to 2.718, which is our constant, K is the rate at which the bacteria grows, and T is the amount of time that has passed. Now moving on to an example problem. Ansuya is a biology teacher and is studying bacteria with her class. They decide to observe a culture dish over time as a fun lab project. When they started, there were 120 bacteria in the culture dish. After 4 hours, there are 520 bacteria. So before anything, you need to find what the rate is to have a solid equation. Once you have the equation, find out what the population will be after 10 hours. So what we know as of now is that our total population is equal to 520, our initial population is 120, the amount of time is 4 hours, the constant 2.718, and what we don't know is K, or also known as the rate. Once you plug everything into the equation, this is how it should look. So the first thing you would do is divide by 120 on both sides. So you get 4.3 is equal to e to the 4k power. And then you would take the natural log of both sides. You would move this exponent in front of the log by using the power property of logarithms. So you have 4k natural log of e is equal to natural log of 4.3. And what you can do is you can actually cross this out because it simplifies to 1 since the log of e is natural log. So now you're left with the natural log of 4.3 is equal to 4k, then you divide by 4, this will cancel out. K is equal to natural log of 4.3 divided by 4. So if you put that into your calculator, you'll end up getting K is equal to 0.36658. Since we have our rate now, we can write our official equation, which is now A is equal to 120 e to the 0.36658 to the power. Now we can answer the second question, which was what will the population be after 10 hours? So our equation is going to be 120 e to the 0.36658 power, and t is equal to 10. So 10. And our unknown is the total population, which is A. So you can put that all into your calculator and it'll give you A. A is equal to 4,690. So after 10 hours, the bacteria population will be 4,690. Now we can make a data table of all the populations per every 2 hours using the equation that we have gotten. So to get the populations for each time interval, you would just plug in t and then find A, which is your population. This is what you should have gotten for all your populations every 2 hours. With the help of this data table, we can create a graph now. On the x-axis, I've gone by 2s, and on the y-axis, I've gone up by 800. So your graph would look like this. And there you go, that's your exponential growth graph. And if the sun starts setting, the sky goes cold, and